Good day to you. So today we are looking at speed, and our objective questions are: what does speed refer to? What is the unit of speed, and how can you calculate or find speed? Remember, our topic is speed.
Hey, good day. So today we're looking at a practical side of doing speed. And as you know, we are doing a series on speed at the moment and how to calculate them and what the objectives are behind them. So I thought it would be wise to do something where we can get our hands on doing a speed calculation. So first I'm going to go through how to do the method behind our practical, and then I'm going to build the practical myself, and you can join me in building it at home yourself, because all of the things I use are usually around your house somewhere, or you can find an alternative for some of the things that I use. Let's jump in. Now we're going to get into the fun part. We're going to look at how to calculate distance, time, and speed ourselves at home. So for this, I am going to use some toilet rolls that I put into a big kind of round wheel, because I do not have a tennis ball. And I'm going to use a ramp out of my trusty whiteboard. And I'm going to stack some books on top of each other. So if you're doing it at home, please find some things, one thing that can roll, one thing that can be a ramp, and remember to get a ruler, and also to get a stack of books so that you can have a incline for your object to roll down. And then we're going to use color tape to fix the bottom of the ramp to the object that it's going to roll over. And the color tape is going to be at the end of our ramp so that we know when to stop our stopwatch. We also have color tape at the top of the ramp, because if we do not have color tape at the top of the ramp, we might release our rolling object at the wrong time or at the wrong place. It might not be the same every time. Then the next part, number 4, measure the height of the desk or floor up to the position where you will release your object, because we need to know how high our object is off of the floor. Number 5, release the object and measure the time the object takes to move between two pieces of colored tape on the desk or floor. Number 6, very important, repeat 2 or more times and calculate the average time traveled between the two pieces of tape. So from number 1, where your speed is 0, to the last point where your speed is stopped or your time is stopped. And then do this for a range of different heights. I'm only going to do one stack, but at home you can change the stacks of books so that you can see what the difference is in speed as you do your experiment, right? So here we have record your results in a table. You have to make a little table for yourself. Use your results to calculate the speed of the object between the two pieces of tape. Add another column to your table or draw a new table to include speed, because we're going to calculate speed. We don't know speed from the beginning. And then remember to put the unit of speed in the column header. This is the very top column of your table. I will show you what they look like now. Next, we have plot a line graph of the results. Put height in the horizontal axis. Which one is horizontal? Yes, the x-axis is the horizontal one. And speed on the vertical axis, that is your y-axis. Include the units on each axis. What is the independent variable in the investigation? The dependent variable in the investigation. Number 5, state 2 variables that were controlled in the investigation, and then explain why each measurement is repeated. Give 2 reasons, not just 1, 2 reasons, and describe the trend in your results. So these are the things we have to think about as we do our experiment. But first, let's get to the fun part and actually build our experiment so that we can see what we can find. See you in a moment. So we're back in the whiteboard. This means that we have to explain something. Remember in the PowerPoint, we saw that there is a results table that we have to use. So here I'm going to show you what your results table looks like. You're going to make a table that looks like this, and you're going to make sure you have space for three things. The first one is time, have distance, which is measured in meters, and lastly we have speed, which is measured in meters per second. I'm sure that your tables will be a lot neater than mine, but here, make sure you have about 5 or 6 spots to complete your investigations because you need to do averages. That means it's good to have more results rather than less results. So we can number them 1, 2, 3, 4, 5. And now, while you do the experiment, you can continue to put your data into this table so that you do not forget your data by the time you have to analyze it on your graph. So let's take a moment and build our experiment.
All right, so as you can see, we're on the floor of my room and I've got my toilet rolls and things ready. So we're actually going to build the ramp from this angle because it works better that way. Give me a moment. Also remember, don't forget your ruler. I almost did. We have made our ramp a little bit bigger. Let's do a test run. And we can let it go and then it will start rolling. So we can say this one goes about 30 centimeters. So we will put our next one here, put our stickies down and our ruler, and then make sure our ramp is still in place and we can change the sides. Alright, so remember to start your timer. There we go. Alright, so number 1, that's been done. Let's go back to the computer and do our calculation.
Hello and welcome back to my screen. The distance is going to stay the same the whole time. So here should be all the same number. So the distance of my ramp was 30 centimeters on the straight section and 30 centimeters in the ramp itself. Right? So 30 centimeters plus 30 centimeters. And my total distance was 60 centimeters. Since our final distance has to be in meters, we have to change centimeters to meters, which means it will be 0.6 meters. 0.6 meters. This we have to divide by meters. So 60 divided by 100 will give you 0.6. Remember, your calculation will also need to be divided by 100 to get your answer in meters. For my times, I have 2 seconds for the first one. This will give a good average. We have to calculate our speed. So when we calculate speed, we have to remember that our triangle is going to be distance at the top, time right, and speed on the left. And since we are calculating speed, it means that our formula is S equal distance divided by time. As you can see, all of my speeds and so on will be different because my time was a little bit different. Therefore, if we take distance of 0.6 divided by 2 will give us 0.3. 0.3. So your table will look something like this, and depending on how many times you repeated your experiment, your table might be bigger than mine. As long as it's not less than mine, it's okay. Once we've completed our table, I think it's a good time to go back to our presentation and see what we still have to do to complete what we have to do. So as you recall, our step number 1 is to record our results table. And number 2 is to use our results to calculate the speed of the object between the two pieces of tape that we put down, and add another column to your table and draw a new table to include the speed. So we had speed from the beginning, so we didn't have to do that. Number 3, plot a line graph of the results. Use height on the horizontal axis and speed on the vertical axis. So our horizontal axis will be height. Height is the distance from the floor to where your ramp started. So if you forgot to measure that, it is a good thing to quickly go and measure that. So the height of my ramp was 12.5 centimeters. And remember, our final results have to be in meters, so that means it will be 0.12 meters. 0.12 meters. Let us see and try and do this in the whiteboard so that you see how we are supposed to plot the graph. Alright, so here we are back in our whiteboard, and we are going to look at drawing our graph. So remember, the height has to be on the x-axis. So height in here, and the speed will be on the y-axis. Good. So we can add a text box. Colorful. So we have height, bottom, in meters, and on the other side we have speed. Meters per second. Now we have to use our data, of course. We can't just make anything up. So first things first, let's put in our measurements. Yours will be more accurate than mine because you're actually going to use a ruler to make sure that everything is right. So we have 0. Right, so at the bottom we have our 0 mark here. And then we will have our heights, which will be 0.11, and we want a nice big scale so we can easily see what's going on. And we will have 0.12. Then for the other side, you need to refer back to your data. So your highest speed and your lowest speed. My lowest speed is 0.3 and my highest speed was 0.75. So because I have 0.75, it will be advisable for me to break it down into single digits. So 0.1, 0.2, 0.3, and so forth. Right, so now we're going to take our numbers and put them on the graph. That means when I add 12, which stays the same, we will have the different speeds that go up to that. So clearly, because our height stays the same and our speed is changing, we will only have a cluster on the right-hand side. So we're going to plot right. In the next part, don't fret, this is what yours looks like, because we have to draw a line of best fit. And what is a line of best fit? It is a line that goes through the middle of all your data, from 0 to through the middle of your data, that shows what is going on. We will start our line at 0, and we will pull it through asked all of our data so that 50% is on the one side and 50% is on the other side. Because remember, we're looking at the average. So this line shows us roughly where the average will be when we calculate it later. So there were 3 on this spot, and the other 2 are on this spot. So that's why the average is between these two, between the left side and the right side. That's your line of best fit. It does not have to go through all the different crosses. We just want the average. Remember, we're working with average. So that is it for our graph section. Let's go back to our PowerPoint and see which other 4 questions we need to answer. So here we are at number 4 in our questions we need to answer. What is the independent variable in this investigation? Independent means it is not changing. It stays the same. So even if we make various different changes and we do not change this ourselves, the amount for it will stay the same. Therefore, the height that we're working with will be the independent variable. And this is on the horizontal x-axis. And secondly, 4b, we have the dependent variable. The dependent variable in this investigation will be on the y-axis. So the y-axis has speed on it. So speed is changing the whole time, not the height. And the time that your height will change is if you add some books or take some books away from your ramp. Number 5, state 2 variables that were controlled in this investigation. Number 1 will be the height of the ramp, and number 2 will be the top of the ramp to the bottom of the ramp. So between the 2 stickies that we put down. Those are the 2 controlled variables. And then number 6, explain why each measurement is repeated. Give 2 reasons. So we repeat some measurements so that we can eliminate any mistakes we could be making. That's the first reason. We try and eliminate mistakes by having more measurements. The second reason is if you accidentally put the toilet rolls in the wrong place when you release them, or if there is a problem in your instrument when you are checking how long it takes for your toilet rolls to roll down your ramp, it will allow you to also make your errors less. So if there are any mistakes that you cannot foresee or your apparatuses are not properly working, then this will help to decrease the amount of problems. Then number 7, describe the trend in your results. So for describing the trend in our results, we will have to go back to our speed height graph. And in this graph, you could have seen that if we drew a line through all of our crosses that we plotted on the graph, it would have been a straight line parallel to the y-axis going from the 0 all the way through to the top at 0.75. And this means that we did not change the height during our experiment. But the speed changed during our experiment because the time was our other variable. We can also say that our line of best fit had 3 crosses plotted below the line and 2 crosses plotted above the line because we had 5 different data sets. So this is an uneven number, meaning that the line went through the middle of them as far as possible. We also had 3 plotted points on 1 point, so they had exactly the same results. And this can also happen quite often. We just have to remember that there are 3 points on one area plotted. And this also helps us to know how accurate our experiment was. Did we leave the experiment in the right place? Did we add any forces that we were not supposed to? Did we influence it in any way? So this helps us to know what's going on there. So you will obviously use your graph that you plotted to describe your results. And in conclusion, I would say it would be better in future to make more measurements based on the toilet roll investigation, because sometimes the toilet rolls went left and right instead of going straight down. We could have also increased the weight of the toilet rolls to allow them to go a little bit further so that the time that we measure is not so short. So if you are able to, I highly suggest that you play around with how you did your experiment and see how you can improve your experiment as well. I hope you enjoyed this video. See you next time.